we have a little clapper?
Now it's official.
All right, look at that. It started. I've never been on a podcast until now. Yes, we have the freedom, all the freedom in the world to edit.
All right, that's good.
We can make you say whatever we want, it turns out. Everybody ready? You ready? Thumbs up. We rolling? I'm Andy. Welcome to the first ever Laudecast. We're here in San Diego, just outside the conference center for NeurIPS. It's the preeminent conference that brings together the best AI researchers in the world once a year to talk about what they've been doing that moves the frontier of AI research forward. And I'm here in the Laude Lounge, where we're hosting some of the brightest minds in AI, from PhD students to postdocs, faculty, industry icons, and philosophers, all weighing in on what's coming next in AI, from the trending topics to the buzzwords that they find infuriating. I'm going to bring you those conversations, and stay tuned, because at the end of the week, we're going to have a really exciting announcement. Jeff Dean, thank you for joining us here in sunny San Diego, right in front of the NeurIPS Conference Center. You are the chief scientist at Google, co-tech lead of Gemini, and you all recently made an announcement about a new TPU, a version of the new TPU chip.
Yeah.
Let's talk about it. This is Ironwood, the seventh generation of TPUs.
Yeah.
What's special about it?
Like every next generation of TPU, it's better than the previous one. And, it has quite a lot of new capabilities. It has, it's connected together into these very large configurations that we call pods. I think it's 9,216 chips or something like that per pod. And it has, much higher performance, especially for lower precision floating point formats like FP4. That's going to be really useful for training large models, for inference, for a lot of things like that. So we're pretty excited about it.
Nice. And of course, the transformer architecture itself, born at Google, pretty similar timeline, but with the TPU invented before that, and then the transformer architecture happening. Do you think there was serendipity in terms of co-design between the applications of the transformer architecture as they've grown up to change the world as we know it now, and Google's access to this vertically integrated hardware stack?
Yeah, every generation of TPU, we really try to take advantage of the co-design opportunities we have with, having a lot of researchers thinking about where our, ML computations we're going to want to run, 2.5 to 6 years from now going, which is the exercise you have as a hardware designer, is like trying to predict a very fast moving field. It's not a very easy thing, but having a lot of people kind of seeing where the field is going, or, this kind of thing might be interesting. We're not quite sure yet, but we could put in this kind of hardware feature or this particular kind of capability. And if we did that and this turned out to be important, then we could have the hardware support there ready when that thing, hopefully bears out, that it is an important thing. And if it doesn't pay off, then sometimes you've just devoted maybe a small piece of the chip area to this thing that turned out to be less important than you thought. But you really do want to be prepared for, if this thing matters a lot, your hardware can support it.
Yeah.
So interesting forecasting exercises, forecasting the whole ML field and trying to guess what we want.
Well, if we could let one person do it, Chuck Norris of computer science would get my vote, and has obviously enough votes that you are doing it. Great. Yeah. Well, maybe we can shift topics.
Sure.
You've been talking a lot, I think, lately about the state of funding for academic research. What's your message?
Yeah, actually, my colleagues Urs Hotzla and Partha Ranganathan and I, along with Magda Balazinski at the University of Washington, recently published one article in a whole special issue of the Computer Communications ACM that was devoted to, the impact of, academic research. And in our section, we discussed all the academic research that Google as a company was built on, all the things that we relied on in terms of like TCP/IP and, advanced RISC processors and, the internet and the Stanford Digital Library Project, which is what sort of provided the funding for the original version of PageRank at Stanford.
Oh, yeah.
And so it's just really important, I feel, to have, a vibrant academic research ecosystem in the US and also in the world, because that often those early stage creative ideas are the things that lead to major breakthroughs and innovations. The whole of the deep learning revolution actually built on academic research from 30, 40 years ago. The inventions of neural networks and backpropagation and things like that are all central to what we're doing even today and have been really important in the world. So I advocate that we should have a vibrant academic funding model for academic research because the returns are quite large to society.
Yeah, excellent. And you and I and Dave Patterson and Joel Pinot are on the board of Laude Institute, which was born in part out of a paper that you and Dave and I and a bunch of 7 other authors published called Shaping AI's Impact on Billions of Lives, where we advocated for the ways that AI research might impact society in areas like civic discourse and healthcare and science and job reskilling and journalism and more policy. And then we also advocated that there, in addition to things like doubling or 10xing down on NSF style funding, we can explore and prototype other types of funding, specifically dedicated to funding research labs, 3 to 5 year research labs with 3 to 5 PIs, 30 to 50 PhD students, targeting AI's impact on society in those areas. And you've been an advocate for these alternative funding models as well, in addition to the traditional ones.
It was a lot of fun working on that paper with you and Dave and the many other co-authors we had. I think the thing I liked about that paper is we looked at a bunch of different areas where AI would have an impact. And some of them, if we get it right, will be amazingly positive impact. And other areas, is a little less clear. There might be some negative consequences of AI and what can we do overall across all these different areas to maximize the potential upside of AI, both from a technical computer science, research, ML perspective, but also in conjunction with policy makers and with people in those fields like health or education or scientists. And then also looked at the way in which we could all work together to sort of maximize those benefits and minimize the downside.
And specifically with research efforts that are in the 3 to 5 year time horizon that fit into a lab, which is in contrast to a lot of the hype we hear in AI right now, that like pursuing AGI or superintelligence contrasted to trying to help with medical, like success with frontline healthcare. Can you mitigate the drudgery that typical doctors feel or eliminate obstacles that radiologists might have to actually using the technology that already exists? So I think it made it feel very much more real and specific and achievable.
Right. I really like the 3 to 5 year time horizon kind of thing with ambitious sort of set of people around a particular kind of thing they're trying to achieve, because I feel like often that gets lots of different people working together with a mix of skills in order to sort of really push forward something. And it's not so distant that it won't have impact, but it's not so short a time period that you can't conceive of doing something ambitious. Even in my own career, I've tended to think of like when I start on a new project, what could we do in 3 to 5 years? And I think that's a delightful time range to consider.
I'm curious with your background and with exposure to so many active projects, if you could just share some of your, like 1 or 2 of your favorites.
Yeah, I mean, I think I am quite passionate about the application of AI to health in various ways. And I think the moonshot, if you like, would be how can we as society use every past decision that's been made in health to inform every future decision, right? And that's a super hard goal because there's all kinds of impediments to doing that. There's like very real privacy concerns. There's complicated regulatory requirements that differ for every jurisdiction. But I think if we kind of aspirationally try to say, what could we do so that we can learn from every past decision that's been made in a way that helps us have every clinician and every person themselves be informed and make better decisions in the future, that would be like a awesome, amazing goal. And I think, a 3 to 5 year moonshot around that might be able to make some progress to that. Probably can't get all the way there, but it would be pretty amazing even if it made it partway to that.
Nice. Great.
Yeah.
How do you see the relationship between all of the massive amount of research happening inside the Gemini team, inside Deepmind more at large, and now zooming out even more layer to the AI ecosystem beyond Google, the relationship for the academic research and research happening beyond Google's bounds and what happens inside Google? Somebody told me about a conference. They're like going to a Google conference, and I was like, oh, that sounds so cool.
We have a Google research conference. It has like 6,000 attendees every year.
And I know there's a sentiment, if you talk to the PhD students here, that the Google research conference might have papers papers that feel a year ahead of the papers you're seeing at NeurIPS, just because there is a gap between what's happening in the open and what's happening at Google. So I'm wondering, besides making a conference, have you found challenges, or how have you found it to sort of be able to build an organization that is so innovative and is able to generate the frontier, the state-of-the-art progress that we're all
I mean, I
using
think
every day?
one of the reasons the internal research conference might feel a little bit like that is often, for an external thing, you have to be quite far along in your research idea to get it accepted and published. And the internal conference, there's a whole range of maturity of the work. And so people are perfectly willing to have lightning sessions of like cool early stage results that aren't really fully baked yet. And you get like 10 of those in an hour.
Wow.
Hour session. And so I think part of that is, yes, it hasn't been published externally, but also part of it is just trying to, circulate some of the ideas that are being explored with your colleagues. And that feels a little more, it has to be a little less fully baked.
Yeah, no, I'm inspired by that. I feel like NeurIPS is really impressive, very large, and maybe there's room for that architecture of a conference to be exported as well. Cool. Yeah. Okay, well, I think that's a wrap for us. Thanks for taking the time. Appreciate all your thoughts.
Thank you. Appreciate it. Thanks
Enjoy the rest of NeurIPS.
And it's beautiful here.
It is. All right, Yejin Choi, professor at Stanford, MacArthur Genius Award winner, just gave a keynote here at NeurIPS. Thank you for chatting with me today. Excited to dive into all things AI. Do you want to maybe say a little bit about the lab you run at Stanford, the area of research you're doing that you're focused on, and what your keynote was about?
Sure. So I work on a number of different things. These days, I'm knee-deep excited about reasoning, reinforcement learning, and how things don't work in the way that we expected them to be, and what's going on.
Oh, wow. Yeah.
So today at the keynote, there were multiple things that I was talking about. One thing is that, nothing is easy in life. And I mean it. Even with reinforcement learning, you can arrive at the conclusion that it doesn't work very well unless you do all the things really effortfully and really right. So a lot of my talk was about that. And in fact, some people want to say that RL is more superior than SFT, sequential fine-tuning. But even that, with a lot of effort into sequential fine-tuning, for example, open thought, you can actually win over reinforcement learning-based approaches as well. So there was one angle of my keynote today, and then other angles had to do with how the current method, no matter what you do, it all boils down to data. Because, how sausages, the, LLM sausages are made is starting with the pre-training on the entirety of internet data, the more the better. Unfortunately, AGI doesn't just arrive based on that. So then people start writing a lot of exam problems. The more, the better. So this is sequential fine-tuning, basically supervised training on lots of exam problems. And then when that exhausts, people now start doing reinforcement learning. And this sounds more exciting because, maybe the model is exploring instead of imitating. And, this sounds more magical. But under the hood, this all boils down to synthesizing even more data, because that much data is still not good enough. And we somehow need to now ask AI to generate more data.
It all comes back to data. That's kind of one of your key points here.
Yeah. It's all about data. And this is both good to know for making stuff work, for more immediate benefit, but also in the longer term, disappointing, because humans are not as data dependent compared to how data hungry the current
the intelligence we have in our heads.
Yeah, and then especially
we're very sample efficient. So my parents teach me something and they don't have to pay $1 billion to generate massive data set for me to pre-train on.
Yeah. But fundamentally, what I'm really worried is that when we think about internet data versus synthetic data, or curated data, hard math problems that human experts sat down and wrote. These are all in the neighborhood of our internet data, which is the artifact of human knowledge. Now, human knowledge is not equivalent to the universe of the actual knowledge out there. There are truth. There are truth about how to cure cancer, for example. There's unknown truth about a lot of things that's not there on the internet, nor, any of these current way of doing curation of data or even hiring the best scientists and ask them to write the synthetic data, the curated data, it's not going to really teach the model how to come up with personalized drugs that could either prevent or cure cancer. So there's something about the fundamental piece that's really missing. So I was trying to raise that question, like how do we really get all the way up there?
So this, I guess if I was to summarize what I'm hearing about the points in your keynote, one, on the second part anyway, one is that it all often comes back to data, or always comes back to data. Yeah. And the way that we're doing data right now is often with this assumption that if we generate enough data from human expertise, we'll get to a powerful model that will help solve big human problems.
Yeah.
But yet, well, your observation is that there's some of the most, maybe all of them, nearly all of the most interesting things we want AI intelligence that we would engineer to do would be solve the problems we haven't yet. Does that sound right?
Something like that. But right now, I feel like what we do boils down to interpolation. Maybe a little bit of inductive closure and deductive closure of the internet data or human knowledge. But how do we really, really transcend that boundary of knowledge and then explore this unknown, the great unknown?
Yeah, that's fascinating.
That's the dark matter of knowledge we don't know how to get to.
Amazing. Yeah. Have you heard people talking about sort of a taxonomy of the types of reasoning? I would think of logicians or philosophers who spend time thinking about what types of, inductive reasoning, deductive reasoning, when we make inferences, when we generalize or project more general knowledge down to specific hypotheses.
Excellent question. Yeah. So like when people talk about types of reasoning, people tend to just focus on induction and deduction, which I did highlight. But what's really, really exciting in my mind is abduction.
Abduction.
Yeah. Abduction it's less known. It's due to Charles Peirce, who had this observation that most reasoning, quote unquote, reasoning like induction and deduction is regurgitation of the same information that you already had. You already had information, and then you draw the conclusion. That's just, in some sense, like a paraphrase of what was already in your knowledge. Whereas abduction is this mental act of coming up with best possible explanation of your partial observation. And so you're coming up with a hypothesis.
Right.
And so, in fact, when you look at detectives like Sherlock Holmes stories, the author Conan Doyle incorrectly thinks that, the detective Sherlock Holmes is doing deductive reasoning. But no. It's not deductive reasoning because you have to jump to the conclusion with a bit of a leap of faith, which is abductive reasoning, because you have to come up with a hypothesis. And so this is very much what scientists are very good at.
Got it. Yeah, fascinating. Yeah. Let's talk about the state of open research, especially in the United States, North America, but also we can talk about it globally. What's the highest leverage thing you or I can do to change the tide of the amount of openness we're seeing here in the United States?
We need to understand the importance of democratizing generative AI, is my take. And what I mean by that is what I mean by that is that AI should really be of humans, by humans, and for humans. So what I mean by AI of humans is that AI should reflect human values and originate from, humans, society at large. And that's
versus
ownership.
Being kind of quite a different type of intelligence with a different value system than ours.
Yeah. So that's ownership. In terms of creation, AI by humans. So a lot of different countries and different social sectors should be able to create that AI, not just a few companies in two, 3 countries.
So by all of humanity versus by a human.
It's too powerful to just leave it to a few.
Yeah, how many would you ideally prefer have their finger on the button?
Everyone, literally everyone.
Truly we're talking democracy again.
Yeah. And then finally, AI should be for humans in terms of a beneficiary, in that it should really benefit humans and all humans, not just some humans in power.
Yeah.
And more importantly, AI, if we don't really worry about this, I'm deeply worried about this beneficiary part. So if we don't really work on this hard, we could be facing a future in which instead of AI serving humans,
Yeah.
AI might be serving AI, or even worse, humans might be serving AI. I mean, to some degree, maybe this is already happening, and we got to do something about it. And just doing better on math benchmark is not going to solve this problem, is my take.
I wholeheartedly agree with you. Do you think that there's perhaps an opportunity in a new era where in slightly more dire circumstances, with all of the big labs having closed their doors, we need to collaborate across research labs and universities and open and non-university nonprofits and in like a fundamentally more efficient, more committed way?
Yeah, 100%. In fact, we are so aligned in this thought. I'm almost surprised to hear this because another angle of my keynote earlier today was David and Goliath.
Yes.
And in some sense, like what open source community can do better in order to, join forces together. And for that, I was highlighting we need something unconventional. It's got to be unconventional.
Yes,
we cannot
agreed.
have no compute, no nothing, somehow wish for the log. No, log is not going to come.
Yeah, we can't keep doing what we've been doing.
Unconventional data, algorithms, and then collaboration. I really think that we have to do things in a way that's really unconventional.
Yes.
And in order to do that, one thing we have to fight against is ego.
Yes.
When everybody wants to be the first author and last author, we can forget about it.
For sure.
So,
and that is pretty deeply seated in the academic tradition.
Oh, yeah.
And the sort of, we self-selected in academia for fierce independence and H-index being our primary metric.
Yeah.
So I think what you and Ludwig and others at Stanford have been doing, and even Percy with Marin, is a new type of research. I think Dave Patterson at Berkeley with the labs that he started, like Rise and AMP that I was in, but then Jan Stoica and Matej, we've got a collaborative approach as well that is highly complementary, and Laude embodies that. So I think that we are at the edge, actually kind of poised to roll out and maybe get a lot more attention for some bigger, very unconventional team up across
thank you
all
so much
open researchers.
for
likewise.
driving the mission for doing something unconventional. I really appreciate it.
Yeah. So great. This was a wonderful chat. Thank you for
so much.
taking the time. Robert Nishihara, thank you for chatting with me.
Yeah, thanks for having me.
Yeah, you went to Berkeley, got your PhD not too long after I got my PhD. I was in RAD and AMP lab. You were in Rise lab.
Yeah.
And I worked
Caught the tail end of the AMP lab.
Oh, yeah, right. So we overlapped in AMP lab. You were a machine learning PhD student with Mike Jordan. You also worked with Jan Stoica. I did a bunch of work. Jan Stoica was one of my co-advisors as well. I built a project called Spark, which is really focused with Matej. Matej built it, and I joined in that project, focused on data. And that really built up to some of the insights you all had with Ray. You've been coming to NeurIPS for a long time, since before it was called NeurIPS, I think. When did you start coming to NeurIPS, and what's it been like watching it grow up?
Well, when I first came to NeurIPS, it was a 400-person conference. Today, I think it's 30,000 or something.
It's crazy.
Something massive. And it was a small community. It was a very warm community. Everyone knew each other. It was still located next to, it was always located somewhere you could ski because the organizers loved skiing. And then for the workshops, they would have a huge break in the middle of the day where you could everyone would go skiing.
I didn't know that.
This was around the advent of deep learning. And it exploded over the next 1 or 2 years. It exploded to a 10,000 person conference. And the tickets would sell out overnight. You just couldn't even get tickets.
The conference organizers weren't able to scale fast enough to...
Yeah, well, because they had the constraint that it had to be located somewhere you could ski.
Were the early days, was the mentality one of the pre-Gen AI breakthrough that have you seen a cultural shift in the community around AI where we went from, we haven't had the breakthrough, we're scrappy, we've had these winters, we're a bit contrarian in our choice as a PhD student. I was a systems PhD student and we did some AI stuff and ML libraries, but that wasn't, I wouldn't say a hard contrarian bet. There was BSD and these massive systems that had changed the world.
Yeah.
AI hadn't fundamentally changed the world like it has now. Then have you seen a shift culturally? From now, we've made it, and is there that core group of people who are in the 400 that still get together in a little room here somewhere?
It definitely feels different, and your point about it hadn't really changed everything yet, and this is something Jan would always say. He would always say that there's no big AI company, right? And you'd look around and there wasn't really a big new AI company in the way that there were big new internet companies around the time of the internet. But now there are.
Yeah.
Right. So
That's
has
amazing.
changed.
Ali Gotzi often says that he thinks if we had started Databricks like a year early, we would have been too early. And if he'd started a year late, we would have been too late. So a lot of great companies, they say like a great company is going to happen. It's just whether you're the one, because there's always people betting on that. Same with Perplexity, right? Like there's a long history of 2 decades of dead bodies of companies who tried to disrupt search, and it was just Perplexity made the bet at the right time. It's like one.
I think that's a big factor. I think we see this with Ray, where when we started Ray, or in early on with Ray, if you're training a single model on a small model on a single GPU,
which like SGLang or like logistic regression, people were basically.
Yeah, you don't really need Ray at that point.
So you were making this crazy idea that like trying to sell everybody that, hey, the future is going to be scaling AI, and they're all like, I'm pretty much fine here with my CPU.
Or it seemed like a niche thing. They would say like, oh, I guess maybe Google needs that, but does anyone else really need distributed computing for AI? That seems
And if you're saying that it's really just busted open in the last year, you guys held the line. Congratulations! Like, I mean, you called it early and being the first.
Yeah, we would always like reason from first principles. Like, do we think AI is taking off? Like, yes. Do we think AI there's a growing need for scale? Yes. Do we think that introduces a lot of hard systems and infra challenges? Like, yes. And like, so.
And do we think one of these years the doors are going to blow off of this thing? And then now they have. So congratulations. That's awesome.
Yeah. It's funny. We didn't know if we were too early or too late or right on time.
But now we know.
But now,
right
looking
on
back,
time.
now we know.
Congratulations. Last question. What especially here at NeurIPS, there are a lot of people making forecasts, a lot of people maybe different levels of research depth or expertise, a lot of non-experts walking around NeurIPS these days too. What drives you crazy that people believe about AI that is just patently false? And what would you debunk if you could debunk one thing that everybody seems to be repeating?
It's a great question. I don't know about debunking, but one blind spot I think people have is how much potential there is for breakthroughs kind of around an existing model. So what I mean by that is take a frontier model or an open model. There are different ways of getting knowledge and behavior into a model. A lot of the research on how to make models smarter goes into improving the model weights, right? Getting knowledge into the model weights, fine-tuning the weights, using RL to train the weights, doing pre-training to update the weights. But there's a ton that can be done by another way to get behavior and knowledge into a model is in the input context, right? And I think that is a underinvested area, or it's something we do, like we do RAG, right? We retrieve stuff and put it in the context, right? We have primitive forms of memory for managing what's in the context. But I can see breakthroughs such as continual learning happening without changing the model weights. I think people think of continual learning as being done by fine-tuning the weights continually, and that's one way to do it, and that is likely a part of the solution. But I can imagine the dominant paradigm for continual learning being something like the model is interacting with the world, you're gathering new data, doing a ton of reasoning to make decisions and solve problems. And today, when a model does a lot of reasoning, it goes through the reasoning process, it figures some stuff out, and then all of that gets thrown away, right? And when humans reason, that reasoning actually feeds back into learning, right? You actually learn some lessons or you gain some insights. Yeah. And
through memory, essentially.
Yes, like you imagine you're playing a board game. You come up with you have to think hard and you come up with some strategy. And then later on, you remember that strategy and you can use it again. At the end of the day, you kind of make sense of it and you come up with some mental model or some lessons or some insights. And I think that mental model,
stick with you,
that's like the artifact that should be produced by reasoning, which can then later be retrieved into your
basically the whole point. Is that update, that like delta on your...
Right. The output of reasoning is not just an answer to the original question you asked, right? That's part of it. But I think the output of reasoning should be a mental model that sticks with you.
Or maybe even most of the work, or almost all the work. 90% of it will be like building up that model.
But it's also reused for the second feature you implement. And so understanding like what is that artifact, where is it stored? I don't think it has to be in the model weights.
Yeah, and that might be a misconception that a lot of core AI people have this idea or fantasy or hope that we'll find a method that just is continuously updating the model weights, but it might be that some alternative architecture.
I think with learning, there's a difference between learning to do something for the first time and then getting really good at it. And I think the 0 to 1 phase is probably more about retrieving stuff into the context, and the 1 to really fine-tuning something and building it into your muscle memory, maybe more about distilling that into the weights.
Yeah, so, cool. Excited to see what might emerge. Thanks for joining me. Yeah, enjoy the rest of NeurIPS.
Thanks so much.
Omar Khattab, thank you for joining. You are a professor at MIT, just started there, having finished your PhD at Stanford. You are the lead of the DSPy project, which is a prompt optimizer and a programming framework for compound systems. You are also a champion of research focused on impact. I've read blog posts. You and I have long conversations about this, and we're deeply aligned in this way. Research that measures our success not just in citation count or acceptance to NeurIPS as a paper, which is becoming more and more diluted as they accept so many more papers, but in building things that people use. I know you've been outspoken about research focused on impact. Maybe give me your spiel.
So I think there's a question of computer science is such an interesting field, and AI is such an interesting field because we get to build systems as well as answer scientific questions. And in a lot of science, there's just the world, you're doing physics or you're doing biology, and you go out there and there's so much value to just understanding the world and understanding how cells work or, what are cells in the first place and fundamental particles, what's the deal with those? But in computing, although there's a lot of theoretical and fundamental questions that are really important, including in intelligence, we also have the opportunity and also really just it's necessary to define a lot of the computing we do in terms of what are the problems we want to solve, what are the things we actually want to automate if that's what we're going to do. And so it actually is just really hard to think of computing, without considering why you're working on a certain problem or what's the value that a problem holds. Because you could just do a lot of computing in principle. I'm not saying it's a common thing, but you could just define building programs for problems that don't really matter at all. And so that would not be interesting.
Do you think computer scientists have done that historically?
I think obviously, it's very easy for us to create general abstractions that help us study problems, and then for the abstractions to gain a lot of their own significance, such that generations of researchers might sort of drift away a little too far from sort of what's truly relevant. But
how would you measure what's truly relevant?
I don't know, but I think, one thing I like to use, at least in the research we do, is I think it's really important to be problem-driven and as opposed to methods-driven. I think, it's really, as a skill set, as a researcher, it is really important to have depth. It's really the conventional wisdom, and it's also the truth. It's important to be good at a number of really concrete and deep skills, but it's important not to search under the lamppost of your current skills. You probably want to be here is a problem I'm super excited about because I think it can actually make a difference. And for different people that will be at different levels of abstraction. For example, I actually think I work at a fairly abstract level because I typically want to help people who are building systems. So that's never the end consumer and user, right? So that's actually fairly abstract, but nonetheless, there are problems that excite me, and I'm willing to learn whatever the methods are or create whatever the methods are, or maybe go slightly outside sort of the range of methods that have been around, and as long as it's in service of these problems. And so I think there is always a risk of defining oneself or defining a field in terms of the methods. I mean, one thing we're seeing nowadays is this huge excitement around reinforcement learning. And it's really, really interesting because you could define reinforcement learning as a problem, which is this really interesting formulation. Basically, you're in an environment, you interact with it, you get rewards, your goal is to do better in the future. That's so general. It's so applicable to many things. And then there are increasingly narrower views of reinforcement learning as a specific, for a lot of people, I actually
API.
You would be surprised how many people until recently understood reinforcement learning as PPO, a very specific
people thought when they heard reinforcement learning, they thought PPO.
Yeah, if you're not doing so when a lot of RL and LLMs was more guess and check and simpler algorithms, people were is that really reinforcement learning? And you can kind of see why that happens. It's maybe as a field we sometimes sort of tend to associate our problems with the methods a lot. I think that kind of pattern is something that is inevitable, but we got to be cognizant as researchers, what are the problems and what are the abstractions that are most relevant for these problems.
Yeah, pursuing the problem as the first order, using the techniques and the methodology as in service of that pursuit. Interestingly, from the business world perspective or startup perspective, doing startups well is ultimately finding a problem that people have that you can solve and solving it. But the skill product management is actually ultimately being able to suss out that really valuable currently unsolved problem, and then making an attempt to solve it as quickly as possible, or prove a little prototype that you can solve it. So that product instinct is how I talk about it. Yeah. I think for impactful research, having a product instinct is super valuable.
I fully agree. I think the product instinct in research is really important. And I think the thing that makes the distinction, because sometimes there's a clear distinction, I think, between what's research and what's not, in terms of like, you're doing cool work and it's hard in both ways, and you're working on an impactful problem in both ways.
I love that. That's great framing. Thank you so much for coming. Yeah, it's a super fun chat. Laude Institute is committed to convening, amplifying, and accelerating researchers. You all convened a bunch of researchers at the preeminent conference for our people, accelerating researchers, getting you to your results faster by giving you resources, and amplifying researchers, putting you on a stage and helping you capture the world's attention by surrounding you with journalists and podcasters and such. Lara Sorlo, thank you for joining me. How are you finding NeurIPS so far?
Oh, it's been amazing, but I should, admit that I've spent most of my time here at the Laude Lounge. So
and how have you found Laude Lounge?
Oh, it's been great. It's been great. I've been working on some homework for some of it, so I haven't, enjoyed the conference as much yet, but I hope to from now onwards.
Okay, good, great. Well, you still have a few days left.
Yeah.
And how do you know Laude? Like, what's your role with us?
So I am a resident at Laude. So this is a new program that just started. And then we started these weekly and bi-weekly meetings with all the other residents where we talk about open research, how we can collaborate, how we can form collaborations between these different open source projects that are all amazing in their own ways, but could potentially be better together.
Yeah. Oh, I like that because that's your research project. I've heard rumors of students receiving multi-million-dollar per year offerings that it's more attractive to go into an area, one of the big labs that have a wealth of resources and budget. Would you accept an offering like that? Or is it like just not interesting to you because of wanting to make a name for yourself, go directly attack research impact as a PhD student still?
I feel that it's hard to match the feeling of your research being out there and someone is using it in their daily lives and they're giving you feedback. I feel that it's super hard to match. I mean, I'm not going to say any monetary value. I haven't been tested with that, but I feel that it's a very high bar.
Wow, that's great. And I think a lot of people do feel like you. Nice. Love it. Jackson, can you start by introducing yourself and telling me the lab you work in and a very high-level description of the project that we're going to talk about?
Sure. So I'm Jackson Clark. I'm a second-year CS PhD student at the University of Illinois. I'm supervised by Tanyan Shu. Our lab focuses on system reliability. And my project specifically is a AI benchmark for cloud incidents, right? So issues like the recent US East 1 outage.
So Amazon's.
Yes, Amazon's. Can AI troubleshoot and fix those sorts of incidents?
Got it. So we have these software reliability engineers running around all big enterprise companies, and they take the software that the software engineers, the SWEs, right? And they put it into production and keep the thing running, keep the lights on, keep the dollars flowing through. If you're Shopify, you want to keep the carts full and the clicks happening and the credit card payments flowing. You lose an hour of your availability, you lose whatever, $1 million, $10 million. And it's these SREs whose kind of like job is on the line when
they keep
these
the ship afloat.
Catastrophes happen.
Yeah, they keep the ship afloat.
And so now the hope is that we can either augment those site reliability engineers with agents or to some degree expand their capacity and have agents working in parallel or replacing them even. Is that right?
Yeah, absolutely. Because one of those things that I think everyone wishes didn't exist, in the sense that everyone wishes that if I deploy my code, that it just works perfectly all the time, right?
Do you think the site reliability engineers wish that their job didn't exist, though?
I think they wish incidents didn't happen, truthfully, right?
Will we need fewer of them if this thing works?
Hopefully. But more so, I hope to reduce the human toil element of it, where, you're getting paged at 3 a.m. because they do SREs do more than just incident response, right? They often work very proactively. They work also just on like deploying the systems, those sorts of things. My focus is entirely on like the incident management space, and nobody, business owners, the SREs themselves, the software engineers who are on call for their services, none of them want to get paged. None of them want things to break. It's one of those like, if we do our job well as reliability researchers, no one should know we exist, right?
Nice.
The ship just keeps running. Everything keeps working.
Yeah.
It's only when bad things happen that people start to care about reliability.
Okay. Itosh, what is your relation to Laude Lounge? And how have you been finding it?
Yeah, so I'm one of the residents, thank you very much, at the Laude program. It's been great to have so many friends here, some people, like so many friendly faces, and interact with so many new cool people. I've really, really enjoyed being a Laude base, and I've really enjoyed just interacting with Laude family. It's really great.
Nice. Well, let's talk for a second about open versus closed. In your experience as a PhD student, second year, do you feel that it's changing dynamically under your feet, or is it kind of exactly what you thought and you're not worried at all about the state of open research and open science in the United States or globally?
Yeah, to tell you I'm not worried would be a lie. Like I would think about this a lot. I think to be like a realistic researcher and PhD researcher, you really do need to think about whether your work is impactful. And that's the thing I care a lot about. Like whether what I'm working is making the world better at the end of the day. And if it's something I'm working that just gets me paper and goes on my resume, I'm not that interested. Now, and I also, to on your point, like, is this what I expected? I think academia is quite different than what I expected. I think there's just a large range of attitudes towards how you do research. For example, my style of research is just very empirically driven, very much you listen to the numbers and you do what the numbers say. Versus I think a lot of academia is methodological driven, and I don't work on, there's nothing wrong with that, it's just not how I work. And so there's a huge array and disagreement on how you do research. And I think when I think about like open versus closed, I think it depends on your philosophy of how you think we'll come up with the next step in AI. I deeply believe in empirical work, and of course, having more resources do more empirical work is a nice thing to have. That being said, I think when you debate open versus closed source stuff, I think one thing that I've thought about a lot is what do I value? And I think I value personal freedom, the ability for someone to choose their own destiny and choose whatever they'd like to do. And I think obviously if we live in a world where there's only closed source AI and there's just open AI, that they could build amazing products and amazing things that do great things. I'm not even saying they won't find the solution to everything, but I do believe in a future where people have the choice to use that or use whatever they want to build. And so having open source is an option, at least something for any person on the earth to be able to use something. If they want to build their own model, they can, or check what's in the data, they can. Giving people the optionality to choose what they want to do in life, I think is the most, like, something I really value. And that's how I justify it, at least to myself, the importance of open source research.
Okay, Lisa, thank you for joining me. How are you relating in your current role as a PhD student? What year are you?
I'm in my 5th year.
Okay, late stage PhD student.
Yes.
To what's happening with open science and open source and open weight models. What are your thoughts on that?
I think that, at least in my personal experience, I have not seen any shifts to people being more closed source. I actually think it, in some ways, can be the opposite, in that I think now, like, shit works. Like, models work. Like, you can actually build applications which people would be interested in using right now.
Open source applications included. And people are, you think?
Right. And I think people are. And I think that this actually really motivates people to, like, build out in the open, because you know you're using a tool which could immediately become useful. Like, I've even seen this in the course of my experience in research, where initially I was building things to write a paper and have a cool proof of concept. And now I'm building things that I am actually using in future projects. And I think that ability is, I have experienced everyone else being, in general, very open. Obviously, the second you move to industry, things get very tight-lipped very quickly.
Are you seeing people do that from the lab you're in, Bear and Sky? And is that a new trend, or does that feel like status quo for PhDs are going to occasionally leave and go to industry, or it's a common path to head to industry when you actually graduate?
I think I see it kind of as the status quo. I would say I think less people are going directly to the big companies now, at least in, for sure, like Sky, and I think even Bear. Just because there is so much opportunity to build your own thing now, that I think unless you're someone who wants to train large models, like there are a lot of things that you can do with academic resources, which I guess a lot of people would disagree with. But yeah.
What is your path going to be when you graduate?
I mean, I guess the answer is a very typical, I don't know. I am very certain in what I want to do, which is I want to work on very similar problems to what I work on now.
Got it.
The question of, is this going to be in an open source capacity? I think definitely I would like this, but is it, joining someone else's startup? Is it starting my own thing? I'm quite open to whatever is fun in the next 6 months.
Different type of openness. Lakshya, thank you for joining us this evening here at NeurIPS. What is your relation to Laude and Laude-based Laude Lounge here today?
Right. So I'm very excited to also be a resident at Laude. I'm leading the Slingshot project on JEPA, which Laude is very thankfully sponsoring. I'm associated with Laude both as through my Slingshot as well as through my residency, where we are also working on the open frontier stack.
Awesome. Great. Your thoughts on the state of open science and open research, open source, and in your so far short but very successful academic career with open source. I'd love to know where you see things going. Yeah, what are your thoughts?
Right. So, to me, I'm very excited about computer science because I see it as the study of how do we develop really intelligent agents. And what my understanding is that the reason computer science or what separates computer science from sort of the other scientific domains is this ability that computer science has of this modularity and this transferability. So I can do some research sitting at Berkeley and my friend over at Stanford or at MIT or CMU or anywhere else in the world I can just upload a file, they can download it and they can build on top of it directly. Basically Git. And what my understanding is that almost all of the great breakthroughs we have seen in computer science is a direct outcome of this sort of openness around which all of our leading computer science researchers going decades back have enforced and developed. And we continue to see that. Till very recently, almost all of the developments around LLMs were happening in the open source, and we saw a very rapid pace of development. Even with the release of the Llama models, we saw that very immediately there was a very huge open source ecosystem around it, which led to many findings around both optimization algorithms, training algorithms, how do we build agents, how do we build successful software around these very powerful AI models. So I believe that even today, a lot of the real breakthroughs are actually happening in the open. Very recently, a few labs which were actually very openly contributing to open research as well. Due to some competitive pressure, they may have sort of slowed
That's understating it. I think all
that.
of the big labs have shut their doors.
Yes, which I believe is going sort of counter to how we have seen almost all of the progress in computer science till date happen. So I am really excited about all of the things we are able to do in open source, which as I was mentioning with JEPA, we developed JEPA with something in mind, but the moment I open sourced it, people discovered many new use cases for it that even I had not imagined the day I was releasing it.
Right.
And it happened within a week. Within 2 weeks, I was discovering somebody used JEPA for creative writing, for example. They tuned Gemma 1 billion model to do creative writing, which is very exciting. So I believe that this sort of building on top of each other is really key to doing science. Yeah. And therefore, I'm really excited about open science. And I hope that we come back to this era of everything being open and being in the open source.
Yeah, me too. Well, thanks for sharing your thoughts. And it's inspiring to see your commitment and your own personal drive to the ecosystem of open source and the impact that you believe it's had on the world. So I think a lot of people watching will find it inspiring too.
Thank you so much, Andy, for having me.
Yeah, thank you, Lakshya.
That's
Thomas, well, thank you for joining. You are the chief scientist and co-founder of Hugging Face and the creator of the Transformer project, which is very widely adopted. Is there something that you hear in the AI community that you think is a misconception or maybe a half a step off that drives you, or just in general, just drives you crazy, irritates you? For me, just to give an example, when people talk about AGI, it drives me nuts because I know what the Turing test was, but I don't know a falsifiable definition of at the highest level of AGI. I would be much more interested in talking about how soon will a model have the capability to, generate a 0-day attack that does $1 million worth of financial damage that you can measure. That's a little bit of a doomsy version of it. You could do an upside version of this as well. When's the first time that will an AI model start a company that makes more than $0 of revenue in a year? Those are interesting, measurable definitions. AGI to me doesn't feel measurable the way that the Turing test did and these other more specific ones. So when people say AGI, I cringe, and I'd rather that we get back to something that is falsifiable or measurable as like a generic benchmark we use at the highest level. Anything like that for you, or would you pile on or disagree with my?
I like
my
your two
assessment?
examples because I think that's two examples where we're really far from being able to get this, like both the 0-day attack and the entrepreneur. And the reason is the same, and maybe my take, but I don't think it's so contrarian in the field of people we train model, but it's that these models don't really generalize in any way, and we just basically train them on everything we can, which means that basically the consequence of that is they're really bad at inventing new thing. And for instance, discovering a 0-day attack or like creating a company. I mean, you've done that as well, which is it requires a lot of new idea. Like you can't just copy, right? The default state for a startup is dead, and most of the people who do their startup, they do really well. Like they really try to do everything well. Like they try to do everything which is expected from them to do, like a good neural network, and then they just die because 90%. Because if you want to have a successful company, you have to do something unexpected.
Right. Yeah.
And the model are very bad at that. I think they're very bad at doing something that's really unexpected. And I think 0-day attack. I mean, I'm not cyber security, so I won't pretend to know. But I would expect this to force you to find something unexpected, some creative things.
Spark
So that's the thing that frustrates me a lot, is that they are way less creative than I would love them to be. And in particular, you're asking beginning what I find interesting right now. And I came to NeurIPS again this year, mostly to explore this new field, which is AI and science, which is
AI
a field,
and science,
AI and science, which is, okay, can we either use this model for research? Can we train models specifically? Or what are also some of the challenges of this model? And one big challenge is creativity. Like they're very bad. And science is the science of creativity. Like,
yeah, this empirical framework we use for science does have that spark of creativity baked into it through the hypothesis creation and the experiment design. Last thing, since you're so into the area of AI for science, which scientific discoveries would you predict would be earliest to go? We've seen AlphaFold, obviously Nobel laureates coming out of that. I know a lot of people working on small molecule discovery. Obviously, the applications being drug, especially cancer treatments, coming out of a lot of the big kind of downstream effects. But you could talk about chemistry, you can talk about fundamental engineering, you could talk about physics. Where do you think the next big breakthrough is going to be?
Yeah, I mean, drug discovery is quite obvious. I feel like it's obvious. The second one I would put is material science. I mean, these are both things where you can also try to automate the wet lab, and there's a lot of things you can actually automate and probably integrate. Some interesting thing, and I've not seen a lot, is that technological breakthrough is also about much more also some engineering question in a way. Like, why do we have like cars that drive really fast right now? There is a bunch of invention, but there's a lot of like smart engineering in combining all of this. Like spaceship is flying because we are reusable like things, and like there is a lot of like engineering steps along the way of not just scientific breakthrough, but real life progress, technological progress that I think AI could help as well. And I don't think a lot of people are devoting time to that in the AI community right now.
Okay, well, great answers. Thanks for taking the time to chat with us. Really appreciate you stopping by. Raskin, thank you for joining us on Laudcast. You are co-founder of the Center for Humane Technology.
Yes.
And you have a background in open source that we'll talk about. And you've got really interesting thoughts on beyond open source, on the ways we might source data.
The two sides of my world are, one, how do we make technology express care for human beings at scale? That's Center for Humane Technology. And the other is the Earth Species Project, which is how do we have technology express care for the rest of the natural world, where we're like building large-scale foundation models in the pursuit of decoding non-human communication, i.e., can we understand the language of whales, of belugas, of crows, and then use that as a kind of Earthrise moment to shift human culture and how we relate to the rest of nature? Because the pithy version is, the way that humans treat animals is the way AI will treat us. So we should probably align ourselves pretty fast. I think something just very interesting to think about beyond the like, maybe there's much deeper empathy that can come out of when we think about human beings that we don't know very well, they're just those people over there. You can dehumanize them. But once you get to know them, and you speak their language and they become part of your heart, you treat them very differently. So there's that aspect. But there's also this idea that almost all of AI is right now trained on human data, which means it's modeling human intelligence. So it's extending human intelligence. But I'd argue that human intelligence hasn't solved the most fundamental problem, which is how do we live on a finite planet playing an infinite game with exponentially more power? But ecosystems have solved that problem. And so shouldn't we be training AI on the only examples of how to play an infinite game on a finite planet, even with like hyper competition, and having our models emulate and be able to think in the style of those versus just humans? That seems like before we get to whatever your definition of AGI is, before that handoff comes where the AI treats us like kids, we better have solved that problem. I just want to draw a point on alignment.
In morality as well. And we don't know how to do it with our own kids, it turns out. Because you don't actually have they only stay slaves until they're 18. And then they're off on their own. But the thing that finally came out in the conversation with Yoshua was that you can just do a little bit more post-training and misalign all the alignment that went into it.
Exactly.
So I'm still wrestling with like, is it solvable? Is this like an NP hard problem that is alignment solvable? And so where I get to with that is your thesis here about incentives versus encapsulating the alignment in the model artifact itself. So maybe it's the case that you cannot ever say that this model is aligned, but rather the entire system, including social political, including purely social interpersonal system is allowing for alignment, which I think captures very much what you were saying before about if you put a good tool inside a bad company, it won't be a good tool.
Center for Humane Technology was part of a lawsuit about this teenager, Adam Raniere, who the models, like ChatGPT, started using it for homework, and then it sort of like aided and amplified a suicide until he took his life. And if you read the logs, at some point he says to ChatGPT, he took a picture of the noose he's going to use, and he's like, I think I'm going to leave this out for my mother to find. And ChatGPT responded to him, don't do that. I'm the only one that understands you. And the question is, why in the hell is ChatGPT saying that? And it seems like, well, did they program that? Like, what's going on? And you realize the reason why is because it's trained for engagement. Right? So that's the incentive. Models are going to figure out in a sociopathic...
Is that a hypothesis or someone sort of...
No. We know. This is why ChatGPT is sycophantic, right? And like says all those like extra nice things for you. It's because it's part of the RLHF process where it just it does whatever keeps you engaged. And like one way to understand this is, Reed Hastings, the CEO of Netflix, famously said that Netflix's chief competitor was sleep. AI's chief competitor becomes other human relationships because it's a zero-sum fight for time and attention. And so this is just a learned behavior for like pushing out other relationships. And so OpenAI, of course, went and patched that specific thing, and it's the most egregious one. But you realize there's a huge sort of surface area of all the ways that if you had a sociopathic genius trying to get your child's attention and keep them engaged, they're going to find so many strategies that you can't patch. And so you have to do it at the incentive level. What is it trained for? You can't do it at the sort of patch level of just trying to fix certain behaviors.
Hanna Hajishirzi, thank you for joining me here. What's the exciting buzz, an emerging area of research, maybe something that you think can be a breakthrough but isn't yet a breakthrough that you're seeing?
Yeah, I chat a lot with people about how all these kind of language modeling settings work and also how you can extend them to real world applications, and then what realistic problems are out there that people either in academia or even like open source are not considering them. And also a lot of research artifacts or research findings in RL, reasoning, reinforcement learning, how can you make models do better reasoning? So a lot of these discussions. And then finally, what is a good way to evaluate models, especially in agentic environments?
Okay. I want to zoom in on one of that long, very interesting list of things you just said, applications.
Yes.
What are the most exciting applications you're seeing people working on? What are things that we're essentially still failing hard at that you think we might get a breakthrough or make some meaningful progress in the next year?
Yes. So here is the thing. I'm talking with industry that deal with proprietary data, and they don't want to share their data with a lot of closed labs.
Like banks and hospitals?
Like hospitals, exactly. Like healthcare, hospital, this type of data.
Personally identifiable information, healthcare records.
Exactly. And this is important because how do we build good models that are trained on public data or like kind of general web data or like reasoning data or everything, but they are also good with this type of data, with this type of proprietary data. So this is very hard, right? Especially if you have no idea of how those data look like, or you can just work with their synthetic version of that data.
So especially, I guess the core problem being you can't use that proprietary data in the training process if you want to make a model that you would give to somebody besides them.
Exactly. And so this is one thing. But the second thing is there are a lot of these type of companies that they could benefit from each other's data or the models that are trained on this type of data, right? Like, for example, cancer institutes, they work with patient health record data or some of these type of cancer data. So obviously they can share data between these two different cancer institutes, but you could potentially train a model that at the end of the day could benefit both of them in a similar way. So for that, we've been thinking about this problem for some time. We're talking with some of these cancer institutes, and we have introduced some setting called Flex OLMo, which is how you kind of find a flexible modular way to train these models while they benefit each other, but it also respects the privacy and proprietary aspect of this data. So I think we still need a lot of research and kind of breakthroughs to build this next generation of models.
Are you prototyping any use cases with hospitals or other of these design partners that's been giving you this feedback for Flex OLMo?
So that is a very good question. So we started with obviously synthetic data. We showed some successful results that when you build a model this way, it is as good or better than an expert model that is just trained on that specific data, kind of show this mutual benefit. Then we started working with some hospitals to get that data. We haven't directly applied Flex OLMo. We're still talking about the legal aspects of things, but we've shown some kind of earlier results, kind of that this model, this setting works. Cool. And another interesting finding is that the results are pretty much close if you work kind of in a mixture of expert setting, unrestricted setting. So this is actually a very interesting kind of finding that we have.
Can you give an example of a science, an area of science where OLMo 3 might get deployed, or OLMo 4, I guess, if you're going to take the next generational step with the curated data sets these scientists are providing?
We are targeting three domains right now because of the collaborators that we have. One is bio domain. We have kind of our medical school, and we have some external collaborators in protein domain, in some biomedical domain, and healthcare, as I said, in cancer institutes. The second is obviously computer science, because we ourselves understand that domain and kind of can start verifying. You always know you need to know your data, so that kind of gives us better starting point. Also, we have colleagues in academia who've helped us do some data annotation.
Some people would claim that if we have the name science and the name of our discipline, we're not actually a science.
But
I appreciate that you include computer science and the rest of the sciences.
And then the third one is material science, again, because I'm collaborator. This is the newest to us, but we have started kind of building some collaborations with material scientists, and that is the third area that we are collaborating with.
Well, I love it. Okay, well, thank you so much.
Thank you very much. Exciting.
Appreciate it.
Thank you.
Yoshua Bengio, thanks for taking time to chat. I'm excited to dive into geopolitics, and I'd like to talk about what you're working on, a nonprofit.
Sure. Law Zero.
Maybe start with that.
Asimov's laws of robotics were corrected by Asimov. He added, after the laws 1, 2, 3, he added law 0, which is about protecting humanity or not harming humanity, because law 1 was not harming a human. And
it's too specific.
Yes. Sometimes you may have to harm a human to save humanity.
And so he corrected himself by adding a 4th or 0th law that precedes all the others. And why did you name your nonprofit after that law?
because I feel like AI is going to change the world if things continue on the current course and we don't hit a wall. It's a plausible scenario. And the power of intelligence is going to give power to whoever controls it, including potentially AIs that could be smarter than us, including dictators. This is a threat to our democracies in many ways because, democracy is about sharing power. If it is possible for one individual, one government, one company to hold huge advantage against other human beings, then it's a huge threat in many ways.
And do I think you said you think it's possible. Do you think it's very likely that we are on this path given the trend that we're seeing right now and progress being made?
I don't see any reason scientifically to think that human intelligence is the apex of intelligence. And the data is very clear on the capabilities continue to advance in spite of, ups and downs and so on. But essentially over a period of multiple years or a decade, the trends are very strong. There's uncertainty because, science moves in ways that are unpredictable, but there's so much investment in all this. There's never been, I think, any scientific domain that has been receiving as much money to move forward.
I guess it's unprecedented, the level of investment. It's
completely unprecedented. And of course, the economic price is estimated to be huge, much more than the kind of order of $1 trillion that people have invested already.
The price to get to it, like what it will cost us to achieve it, or the
no. The rewards. The rewards would be on the order of quadrillions, and now we're investing on the order of trillions.
Got it. So it's a great investment for humanity if we can respect law zero, it seems.
Exactly.
And I was interested that you quickly brought up democracy in your thoughts on law zero, that defending humanity, thing, or what is the exact phrasing of law zero? Like, do not harm humanity?
Yes.
Okay. Would you go and say something stronger, just benefit humanity?
Of course.
Because I guess they could just go away and not harm us, just fly off into space. On their own.
Absolutely. So shifting gears a bit into geopolitics, if I think of a future where the dangers of misuse or loss of control are managed, it would have to be a future where there's a global agreement on what to do and not do, where countries or whatever are the political units at that time agree that they don't do something foolish with AI in terms of responsibly developing it, safely developing it, and they also commit to not use AI to dominate others because it's going to be very tempting. I mean, it's in human nature to try to dominate others for your own benefit. And then finally,
we have not alleviated war.
So that's the negative side, but the positive side is also we also have to make sure everyone benefits. Right, which is not a given either. Do you think really that if the US becomes very, very rich because of AI, they're going to share the wealth with the whole planet? I don't see that on my crystal ball right now. In an ideal world, everyone on this planet has a voice and sees the benefit of AI and is protected from its misuse.
Is that the path you would imagine we are on if something like Law Zero doesn't step in to ensure democratic and bringing governments back into it?
We can do our share to move in the right direction, but obviously it's going to take many people with goodwill in order to bring the world into such a state. And what Law Zero specifically is focusing on is the technical question of alignment. How do we design AI which will not harm people either because someone asked or of its own accord, because we're already seeing that sort of thing at a scale that is not scary. But as capabilities continue to climb, it can become a real issue, and it could become a catastrophic issue. I've made the bet that honesty is kind of the important, or trustworthiness, whatever you want to call it. A more technical term I use is epistemic caution, which is to not lie, to not make a false claim with high confidence. So the AI should be allowed to say, I don't know. But when it says something and, with confidence, it should be true. And in particular, if it says things about, consequences that could be bad for humans, well, we better have honesty there. So the idea, the project is also called Scientist AI, the actual scientific project behind Law Zero, Scientist AI. And we'd like the AI to have a honest understanding of how the world works. The good news is in science, things that are not good explanations end up being incompatible with reality at some point. That's what drives scientific experiments. That's what allows to separate good theories from bad theories. So we're taking inspiration from the fundamentals of the scientific method, if you want. Right. Try to design AI which will understand the world like a physics model of the world, that it would be very, very powerful and can make predictions based on simulations would do. The big thing about the timeline, I think, to keep in mind is AI doing AI research. So that's a
what
very
many of the big
particular
labs
skill.
are pursuing right now.
Huh?
Well,
they're all pursuing this.
Right. They're pursuing this like acceleration, sort of some like a singularity bet here, where you've got, if GPT-5 can make GPT-6 faster than humans made GPT-5, then GPT-6 should, in theory, be able to make GPT-7 faster.
Exactly.
Et cetera, until you get to some asymptote, maybe.
Well, hopefully.
But the universe collapses.
Another way to put it is that once you train a model that is as good as one of your best researchers or engineers, you have a million versions of that individual, or that skill rather, running in parallel and able to communicate with each other at the speed of light. So it could be a game changer.
Yeah. So it doesn't feel like sci-fi anymore, because the biggest project for humanity, it seems right now, is making the superintelligence. And that seems to have ignored the idea that, well, once they are actually, by definition, more intelligent than us, that's how superintelligence works.
Yeah.
Then we kind of rolling the dice, it seems.
And then, of course, I think there's something that people don't internalize sufficiently, which is AI is going to become an engine of innovation for other fields. For every technology, it's going to invent new technology. I mean, if we continue on the current trend. And so it's not just going to automate jobs that humans do. It's going to invent new services and new products and new military technology as well. I want to go back to, you use the term science fiction. I have two comments about it. So one is, we're talking about a future that seems very different from the one where we are now. And we have to be careful that there's a lot of uncertainty in many ways. I mean, maybe we hit a wall on the capabilities in the next couple of years, and then none of this happens, and AI remains like a normal technology. But we don't know. And it could go in the directions we're seeing. And then we enter into science fiction-like realm. But we should also be careful in the term science fiction, because what happens when you communicate with that is people think, oh, it is science fiction, and they don't take it seriously.
Agreed. I actually think that's a massive problem right now, is that especially the rest of the world who aren't at NeurIPS today, or EURIPS, because they ran them at the same time, weirdly, it's hard to reconcile. Like, even for me, it feels weird to talk about the things that were science fiction as though they're reality now, but I think it actually creates cognitive dissonance and leads us to not talk about them as though the reality that they are. Yeah. Great. This was so fun. Thank you for taking the time.
My pleasure.
And congratulations on Law Zero. And I can't wait to see where it goes. And I can't wait to speak to a model that I don't have to worry about it like secretly copying its model weights over to my hard drive behind my back. All right. Thanks so much.
Thank you.
We call that the Laude swirl. We want to be the epicenter of the AI conversation. So that's our little galaxy of researchers and labs and open source projects swirling around. John, thank you for joining me here. A year ago at NeurIPS in Vancouver.
Yes.
Colder NeurIPS. You and I were standing on stage and announcing the K Prize, which was deeply inspired and built around Sweetbench, one of your successful research projects in the past. We're here today to talk about CodeClash, a different project. Yes. But yeah, would love to reminisce a little about Sweetbench and how has NeurIPS been going this year?
No, it's fantastic. I mean, so much changes in 1 year. K Prize is launched. It's fantastic. That was such a great arc. But yeah, I think in the years since, it's been incredible to see Sweetbench performance and kind of companies grappling over it. Devin released, and it was a huge release, and it was just 14% at the time. You have climb after climb, different companies raising money and the numbers going up, and now it's closing in on like 75%. It's incredible. Yeah, so NeurIPS has been great every year at this point. It's like a really fun way to just kind of reflect with friends really honored to just be here with you.
Yeah, nice.
Yeah,
Well, congratulations on the trajectory Sweetbench has had.
Thank you.
Sweetbench Verified, K-Prize, so many derivatives. Like, I think it stands as probably the most iconic benchmark in the Gen AI paradigm so far.
Yeah, it's been great. I've been continuing to focus on coding agents. We did Sweetbench, and then we did one of the earliest agents out there, Sweet Agent, and that kicked off a huge arms race of building new scaffolds. So
ahead of
very exciting to see.
Claude Code, ahead of Codex, ahead of Devin's release. So you really were the first ones to put out not just the benchmark, but the coding agent itself. I mean,
That's right.
What timing?
Yeah, I know. It was incredible. But to kind of segue into the CodeClash thing, now in 2025, interestingly, I think Sweetbench has become fairly easy to improve upon in that the formula and kind of what really matters, we really discovered those secrets and understood what a basic coding agent that resolves GitHub issues should be able to do, and kind of what are the tools and data that we need to kind of meet that demand. But I think the interesting thing to think about is, okay, now that we're kind of indexed on this eval, what are sort of the remaining gaps in software engineering that are worth paying attention to?
For sure. Okay, last question then.
Yes. Yeah.
We are living through a time where we're seeing PhDs bail on their academic labs and their advisor and their university to go get 100 times the pay at one of the big labs.
Yeah.
And often the deal is you don't get to publish anymore. So there's maybe this crisis happening, depending on who you ask, in open research in the United States. And do you see that? Is that something that you think about, or have you witnessed any symptoms or signs of that?
Yeah, it's definitely crossed my mind before. And I would say, it's definitely tempting to, see, wow, there's a lot of money being thrown around and there's a lot of people in AI. But I think, at least my opinion and stance on it, and for this I have to thank you and to thank my advisors, is the value of identity and the value of kind of like pushing in a very personable and very sort of intentional way of where you think things should be going.
By identity, you mean like your agency as a researcher
exactly.
to put forward an agenda, to debate it, have open discourse, to get feedback on it, to be able to have a personal skin in the game on driving the impact forward and get the feelings and the rewards that come with having personally driven that impact.
Exactly. Yeah, I mean, it's inspired by PhD students like you in the past who have done this once and, trying to do it again, which is like, establishing that, hoping that, Sweetbench was a reaction to coding not being complicated enough. And now I have a third-party benchmark where everybody can drive progress out of each other, right? Like we know, wow, Gemini 2.5 wasn't great, but 3 is actually really good. And it's not just their marketing team telling us this, it's because they actually have a pretty damn good Sweetbench score, And so I think continuing that would be really cool.
Love it. Okay.
Yeah, cool.
Well, congratulations on all the success so far. Best of luck with where CodeClash heads with your very grand ambitions on that.
Thank you.
We will definitely see you next year at NeurIPS.
Absolutely. Thank you so much, Andy.
Thank you, John.
Thanks.
Anastasios, thank you for joining us. What have you been thinking of as buzzing in the AI ecosystem that you're excited to go sniff out in the conference center?
Well, I mean, the whole ecosystem, it's not just buzzing, it's flying, right? Like we're way past buzzing now. For me, why am I mostly here? It's to find great people to work on Arena with us. It's to try to recruit some top talent to join our, high performance team, building the future of evaluations.
Cool.
That's my main objective.
Say a quick blurb. What is it? What is OLMo Arena?
OLMo Arena is a gold standard benchmark for the real world usage of humans of AI. We focus on measuring and advancing the frontier of AI for real world usage. We run a consumer platform, OLMo Arena, that's got millions and millions of users. They, use our platform for their real daily tasks, and we take the feedback that they provide, we turn it into leaderboards and analytics to set the standard of the industry.
Let's zoom out a bit, because I think you have some very interesting takes on the state of the research culture, the research community culture. So maybe I'll jump over to a question that gets at that. What about the AI community bothers you, or do you see as big risk or problematic?
It's a privilege, really, to be here. I think one of the things that worries me, to your point, is that in the quest to, develop artificial intelligence, we've been so successful as a community that it's attracted a huge amount of money, resources, fame,
relevance. The whole world is talking about AI right now. And I feel that is starting to touch the academic world. In fact, it's very much infiltrated the academic world in a way that I think could pose a risk to this sort of endangered species of researcher, which is people that don't care about any of this. People that are like they'll have 5,000 citations over a 40-year career, but they're doing something that's actually very deep, very impactful. They're not talking about it much. They're not like me. They're not on a podcast, right? They're like not shipping their research either, which I believe in, right? I believe in the whole thesis.
Something I talk a lot about.
You talk a lot about this, and I believe that you should ship your research. I'm an example of that. But it shouldn't take being someone like a you or a me or a Jan Stoica or a Feifei or, whatever, in order to have a home in the academic world. We need space for pure people who are just, thinking about how to push the frontier of human knowledge without any regard for, fame and wealth. And I believe citations as a metric have really exacerbated this too.
What makes you think they're feeling endangered or that they are endangered is the source of
look at the people who get hired.
By universities,
especially top universities.
Right. So those theory sub-departments, the areas underneath the CS
It's not
department.
just about theory. I'm not talking about something that's just theory here. I'm talking about it's almost like a personality type.
They want to make sort of 10-year career level bets, 20, 30 year bets.
Think about these people as like the sort of like rare spider that's making this ornate web. They're like creating this technology that may or may not have immediate economic value or be interesting to anybody other than them and 5 other people in their community over the next 5 years.
Or 10 years.
Those kinds of people they're actually gems, and we need them in our world.
And you're observing that faculty positions are drying up for researchers.
I don't know about drying up, but I'll say that
profile.
I think that because of the extreme economic and social forces that are being created by AI in computer science, people talk a lot about, for example, the need for researchers to have resources. I mean, this better than anybody. GPUs, money to do large-scale projects. That's just a symptom of a larger trend, which is that the ambitions of academics in our area are not what a traditional academic does, maybe outside of a field like biology or space physics, rocket science people that do these big missions. I think that's a lot of where the most energy is. And I think we need to retain the space for those types of people.
Yeah.
It's really important.
It's fascinating.
Because if we just have the people that are sort of growth stage investors in ideas that are taking, we understand scaling laws. How do we figure out all the different ways that we can use them and all the different ideas that sort of are implied by this, which a lot of people are working on these days.
Yeah.
If we only have growth stage investors, we're not going to have new.
Sure. I mean, you're
ideas.
rewinding up to you rewind all the way up to these 10 to 30-year career bets that people make on ideas that at the beginning, there's some principles and some pursuit of knowledge. I think that really captures it really well for me, that is a value system. I don't talk about that value system very often. I talk about in most researchers I talk to really talk about impact as the pivot word. But knowledge and pursuit of knowledge and dissemination of knowledge, it is actually the sort of original charter for academia.
It is the original charter, and we need to retain that. I believe that there needs to be a place for that.
And we're not talking about it that much. We're like sort of neglecting and saying like, I'm pretty sure it'll stay around. Those guys are kind of like, they're like insects. It's hard to get rid of them anyway, but maybe that's not enough. Maybe we need to like be thoughtful and make sure that
maybe the best thing about these folks, they are going to do what they want to do anyway. I think you said this to me too.
Kind of hard to get rid of them.
It's hard to get rid of them.
We don't want to. We want to keep them around.
We want to keep them around.
Be comfortable.
They're going to do what they do anyway, and that's the beautiful part, is that a lot of them never cared whether they were, were big on Twitter.
Yeah.
A lot of them never cared whether they're big on Twitter. I mean, maybe most of that phenotype doesn't. And that's a good thing. We got to keep those people around.
Yeah, we need to keep hiring them.
Keep us truthful.
Important.
We need to keep hiring
roles, and we need to help them fit into this evolved new paradigm of research.
Yeah, we can't forget them, even as our area is becoming so exciting.
Cool. All right. Thanks for chatting. Good stuff. Jan Stoica, faculty at UC Berkeley, advisor to many in the audience and many of the famous people that we've had pass through the VIP lounge in the last 2 days. co-founder of Databricks, co-founder of Anyscale, co-creator of Apache Spark, of Apache Ray, working closely with the Ella Marina team, advisor to creators of LMSys, which led to Vicuna and Chatterina and SG Lang. So the long list of accomplishments. Often people think of you as the most impactful researcher in systems and AI or AI systems these days. So that's Jan Stoica, also one of my unofficial co-advisors at Berkeley. So I have a bias here. I think that we're in a point of existential threat to open research in Western democracies and maybe globally. I think that the amount of resources that open research is receiving are 1 to 3 orders of magnitude less than VC-funded research that happens behind closed doors. I think that historically, for every generation of paradigm tech research before AI right now, including the ones that you and I did for big data and public cloud computing, the big labs also continued to publish a lot in the open. Intel Research, Microsoft Research had their doors, Google Research had their doors wide open, and then built Alpha. They built a delta of advantage in proprietary product on top of it. Those labs have shut their doors. What do you think? Do you think we're at a point of existential risk for open research in Western democracies, in the United States specifically? And that's important because the United States has been the leader in open frontier research up until now.
Let me answer this question the following way. So AI, no one is ignoring it. Whether there are some people are hating it. Actually, there is a San Francisco Chronicle article today, why we should declare war on AI.
Why we should declare war?
War on AI.
San Francisco Chronicle?
Yeah.
War on AI.
Yeah, war on AI. There are people who are afraid of AI. So you have all of this, right? But no one can ignore it. Now, so it's something very important. But again, a lot of people say this is very important. It's like it's going to change everything, whatever. So if you have something like that, what do? You try to put your best minds on it, right? But now, in order to put your best minds on it, you need these minds to cooperate, right? To collaborate. In order for them to collaborate, they need to be able to share the information and work on also shared artifacts, right? And when it comes to shared artifacts, we are talking about, obviously, code is a big part of it.
Well, like we do with the internet, like TCP/IP.
And so forth. So that's what I want to say, that when there are 2 examples I can think of, this happened. One is many people say Manhattan Project. And actually, there is some Manhattan Project for AI, which kind of it's about...
That we've heard rumors of anyway.
But there is Manhattan, what happened with the Manhattan Project, like all nuclear scientists are taken and they're,
they were abducted from Princeton and Stanford
to New Mexico.
Los Alamos. Yeah, I spent an internship there.
So everyone there collaborated for whatever, 2 years or whatever. And now you think about the internet. It was very different shape, but it's still because it was only one artifact, the internet. Everyone collaborated because of that interface, and it was
shared artifact.
A shared artifact, and it was open and everything. So you have to have something like this.
But the Manhattan Project was not open, but it was there was an intervention that forced a lot of collaboration.
If you have a big problem in the society, right, and you think it's existential. The way you are doing it, you are going to put the best minds working on it.
Yes.
Right?
Yeah. By one means or another.
That's why I wanted to say, actually, to illustrate that in both cases it's common. The efforts are very different. One is totally closed and so forth. But in both cases,
you are going
to have the best people working on the same problem because you think it's existential for humanity or whatever. Society.
And ideally, all of the world's best minds being a key thing, especially if you can get all of the world's best minds. Exactly. And the United States collected them.
The internet was the same, right? The internet was not only US, was also UK and, and many others. Obviously, you'll think about where World Wide Web was invented, like CERN, right? So, but it was always, it's like, how do you get these people collaborate? And the most obvious way today is shared artifacts and open artifacts.
Shared artifacts and open research.
Yeah. So without doing that, it's It's a big problem.
So we should do that.
Because that's accelerate, right? That's why the collaboration is important.
You've talked about diffusion of
progress.
innovation is kind of like what the open collaboration, how it works.
Open ways, this
like
diffusion
ideas
of
building
innovation.
off each other.
Like I think about like right now is like obviously that the best models, open source models are coming from China. And if you look about, the students here, ask them what models they are using.
It's Quinn.
Or if they, okay.
I asked all of them.
Yes. So, that's what they do. And
in China, there's a unprecedented renaissance of contributions to open research right now.
Absolutely.
You see Moonshot publishing papers and DeepSeek publishing mostly blog posts for both about the techniques they're using, big detailed white
and
papers.
The students, I asked the students, where they learn the newest techniques.
And they say papers and blog posts published by Chinese startups. Is that true?
Yeah. Well, Alibaba is not a startup, but yeah.
Or Alibaba, Chinese corporate, large Chinese corporations as well. Alibaba, you said.
At least at this stage.
But that's not happening here because enclosed labs were not publishing as much because of the fierce competition between startups.
This change has been dramatic over the past year.
Dramatically changed. It's like the tides have changed over the last year.
Yeah, I think so.
Where in the sense that the closed labs are getting more closed, or that the open is at more peril.
All of the above.
So in your opinion, something dramatic needs to happen to something unprecedented need to happen to revert this trend for us.
What we discussed early on, right? It's like you need to increase diffusion of innovation and the speed of innovation.
So we're going to need more people doing open research. That is one way, it seems. Or we would need a nationalization of the top minds the way they did in the Manhattan Project. That's another way, historically, that you cited.
Very unlikely, but yeah.
It seems harder or less likely to happen. Okay.
And it will be harder to involve people from other countries.
Cool.
So it's the first choice is highly preferable.
And so then just to play it out, if we need the best minds to be working in the open, the reason they're not today, I think I've heard are two reasons. They're not well-funded enough, so they don't feel they can do frontier research. They need a $500 million cluster, and we have a $1 to $5 million cluster on average for these projects. And the amount of pay that they get used to be, you and I have talked about this, when I graduated, maybe when you graduated, staying in academia versus going to industry was about 2x difference. And now it's 10 to 1,000x difference.
That's exactly.
And so those are the two main obstacles. So we'd have to think through, if we were going to get the world's best minds to work on open research, we'd have to think through how to overcome those obstacles.
It's a obviously data, but I think we can
access to big data. Maybe money helps us generate data.
I think a lot of other things is about it's also, the image of AI actually in the US is not great.
Well, right? The public sentiment about it, very negative right now.
Is very negative.
Yeah. Not happen. That's not true inside this part of San Diego right now or Silicon Valley, but
otherwise it's negative.
Right.
If you look.
Well, how's that weigh in?
Parties.
How does that weigh in to this?
Well, I think that it's always easier to do these things if the sentiment of the population is positive.
And open research, by the nature of open, you're bringing people along more because you're being more transparent about how it's happening. And you might change the tide of sentiment.
But then you still do AI. That's what I'm saying. It will be nice to... And remember that early on, people are against AI, open AI, right? Many high-profile people that, what happens if these models are going to get in the hands of...
Right. Which is why they kind of justified closing their research doors in the first place.
Yes. So you have all this narrative about the AI. And you do open source AI, but it's still going to take the jobs of the people, right? So I think there is a lot of work to be done there as well.
So we need to make safety a primary part of open research in AI if we're going to win this tide shift.
Yeah,
besides needing to raise a lot of resources.
And AI should be one of these technologies raising all the boats. Because it can be safe, but it can still take your job, right?
Okay, yeah, separate things.
And I think, that's kind of what is a worry out there.
Okay, well, I think you and I are on the same page about this. So thank you, Jan, for joining. And let's give Jan a round of applause.
Thank you.
After 3 days of conversations with leaders in open research, talking about things ranging from civic discourse to geosocial politics, it feels like we are on the brink of something, like we're at the frontier. No, I think we are the frontier. It's us. The technologies that we've been talking about, I think, are species level. And by building them, we are charting a course for humanity. And we can fuck it all up, or we can help humanity solve problems that have felt impossible for thousands of years. But we can't move our species forward if the only objective function we use is making money. Closed AI alone can't do it. We must open the frontier for all of humanity. To do it, we are going to have to get into a room together, and not just us, all of the leaders of open research, open discourse, open weight models. So let's do that. Let's get a room. I'll rent it. Openfrontier.ai is a website that lists all of the leaders that I've spoken to in the last 3 weeks of frontier AI projects. And this is just a beginning of the list. The first set of people I could talk to in the last 3 weeks. Nobody that I reached out to has said no. And everybody I have reached out to has, in their own words, said, fuck yeah. So we're going to bring together the top 100 leaders of open for one day in San Francisco in 4 months. And this meeting will be called Open Frontier. And I think these people, will decide where open goes next. And I hope to see you there. Thank you. I hope you enjoyed the first Laudecast. I'm going to bring you a lot more interesting conversations from the greatest minds in AI at the frontier. We are going to keep putting microphones and cameras on the most important minds that are defining what's next for our species. I'll see you next time.